The ratio of boys to girls in a class is 3 to 5. There are 21 boys in the class. How many girls are there? So let's use our 4 questions to start this problem. First question, what are we comparing? And we are comparing boys to girls. The second question is, what is the ratio? Well, it says the ratio of boys to girls in the class is 3 to 5. And so we're going to put 3 to 5. And the reason I put the numbers underneath the labels is because I want to make sure to have the correct order. Okay, question number 3. What is the other piece of information? And there are 21 boys. So let me write here, there are 21 boys in the class. And we want to know how many girls. So, you know what? Let me set this up so that my answer is all ready to go. There are blank girls. Okay, and brevity is the soul of wit. I don't have to write that there are this many girls in the class. The less words we use in math, the better. Okay, so there are many methods we can use for this. Today we're going to talk about using a ratio table, which is nothing more than a table of equivalent ratios. So let's see. We can make our table horizontal or vertical. So let's see, I'm going to show you both. All right. The easiest way probably to do it is to rewrite your ratio, which is 3 to 5, and then kind of make the table out of this. Okay. And I'm going to draw my line down here. Okay. So this is what we call a ratio table, a table of equivalent ratios. All right, now remember that a ratio is a pattern that repeats. So I'm going to, next to the table, go back to my original strategy, which is repeating the pattern. Okay, so if I have 3 boys, I'm going to do this. That represents the 3 boys to 5 girls. And if you remember, we said this is a great strategy, but it's too time consuming. So that represents the first line in my table, 3 to 5. What if I wanted to repeat that pattern? What would I do? I would have to add another 3 boys and add another 5 girls. Notice I am not adding the same number to both sides. I am adding according to the original pattern. All right, so actually, let's do this. I don't want to put that in the table. I want to do this. I'm going to have to add 3 here, and I'm going to have to add 5 here. And we are going to get a total of 6 boys and 10 girls. Okay, well, I see in my problem, I want 21 boys. So let's go back. Again, add according to the pattern. I have to add another 3 boys. And that is going to give me 9 boys and another 5 girls. And that's going to give me 15. Okay, and on and on and on. And I'm not going to complete this pattern of drawing the letters, but what I am going to do is I'm going to continue this strategy of adding according to the pattern. So if I add another 3, then I'm going to get 12 boys, another 5, 20 girls. And I have to do this until I get to 21 boys because that's what the question is asking. So another 3 is going to give me 15. Another 5 girls is going to give me 25 girls. another 3, and that's going to give me 18 boys. If there are 18 boys, I have to add another 5, 30 girls. Another 3, that's finally going to bring me to 21 boys, and I have to add another 5, and that is going to give me 35. So if you can see by the table that by repeating this pattern, if I have 21 boys, then there are going to be 35 girls. Okay, and this strategy is called additive reasoning. And additive reasoning is nothing more than adding according to the pattern. Now, it is a little shorter than writing all those letters to do our original repeat the pattern. However, it's still kind of long. And if you recall in your lower grades, you probably learned of a way that you can do repeated addition in a faster, more efficient way. And that's multiplication, right? So we can actually, instead of using additive reasoning in a ratio table, we can use what we call multiplicative. Multiplicative. And you can see kind of the word multiplication or multiply. And multiplicative reasoning is using multiplication or division in a table. So let's look at this. Okay, so we're comparing, we're going to do the same thing. Boys to girls, and my original ratio is 3 to 5. Now watch how easy this becomes. Okay, I have 3 to 5. Now if I go back to my piece of extra information, there are 21 boys. So I'm going to put a 21 under the boys column. Now I'm going to look and I'm going to say to myself, since I'm talking about multiplicative reasoning, what do I have to do, either multiply or divide, to get from 3 to 21? Well, if I know my 3 times tables, I know that 3 times 7 is 21. And what that means is I'm going to repeat the original pattern 7 times. I'm going to keep on adding 3 plus 3 plus 3, and we can see that up in the table on top. Okay, well, if I have to repeat the boys 7 times, I have to repeat that original 5 girls 7 times. And so 5 times 7 is 35. And here is the number of girls. Okay, so that's pretty cool. That's pretty time saving. You can use additive reasoning. You can use multiplicative reasoning. You can use a combination of both, but we're not there yet. So these are just the basics of creating tables of equivalent ratios or ratio tables to solve